Today we're going to talk about how to take a velocity versus time graph that is given to you and turn it into a position versus time graph. You know already that the area underneath a position versus time graph, the area underneath a velocity versus time graph is going to be equal to the displacement. We're going to use that tool to go from one graph to the other. We're going to say that because the area is equal to your change in position, or your final minus your starting, we can solve for the area of this velocity time graph. Since it's all constant velocity, that area is going to be base times height. And we'll use that to find out the displacement for each section of the trip. So starting with this first section, we can look at the first 5 seconds and shade in that area and say that for the first section of the trip, because the displacement is equal to the base times the height, the base is 5 seconds, the height is 10 meters per second, and the displacement is going to be positive 50 meters. Now, that doesn't mean you're at a position of positive 50 meters. That means your change in position is positive 50 meters. If I were to plot this on the position versus time graph, I could start it at any position I wanted to. For instance, if I started it at a position of 100, after 5 seconds, I would have to go up 50 meters. So 1, 2, 3, 4, 5, I guess halfway, 1, 2.5. Right in here would be the area that I would go to. Because again, this displacement is telling me the difference between my final position and my starting position, that it has to be positive 50. Now, starting it at 100 when you have a choice seems weird, right? Like maybe if you have a choice of how to make this graph, you might choose to say, you know what, I'm going to start this graph at a position of 0. So again, you don't know where to start. The graph would have to tell you, or you would have to say that I am choosing a starting position of 0 meters if one's not provided for you. So then to have a displacement of 50 means that if I started at 0, now I can say that the difference between my starting position, that my starting position is equal to 0, I can solve for my final position. Final minus 0 has to equal positive 50, which means my final position has to equal positive 50. So again, 1, 2.5 boxes over at 5 seconds, because for the first 5 seconds, that's how far I traveled. For the second portion of the trip, I'm going to go ahead and look in there and say that again, it's the area under this segment all the way down to 0 on the x-axis that tells me about my displacement. So displacement for the second portion can be found by the base times the height of the second rectangle. And that displacement is going to be 5 seconds is the base, but this time my height is 30. And so my displacement is going to be positive 150 meters. Again, that doesn't mean I'm going to a position of 150 meters. That means my change in position is 150 meters. That means the difference between my final and my starting has to be positive 150 meters. This time, my starting position is 50, right? I'm starting from where I ended off. That my final position from before is turning into my starting position for now. So if I say final minus my starting of 50 has to be equal to positive 150, going positive 150 from 50, add 50 to both sides, and I get that my new final position after this 5 seconds needs to be 200 meters. So I'm going to say from 50, I had to go up 150. So at 10 seconds, I have to be all the way over here at 200. So I went up 50 and then 100. And so that is how I'm going to plot that second part. This next part is nice because this next part is right on 0 velocity. So whenever you're on 0 velocity, your displacement is 0. Again, that doesn't mean you're at a position of 0. It just means you're not changing your position. So for this section right here, I would say the displacement of that third section is going to be the base times the height. And the base is still 5 seconds, but now the height is 0. And so the displacement is 0. Again, I don't go down to a position of 0. That would be wrong. Instead, I'm going to say the difference between my final and my starting needs to be 0. And my final in this case, I'm looking for, but the initial is 200, right? That whatever I left off at becomes my new starting position. So my final minus 200 has to equal 0. So if I add 200 to both sides, that means my final position should stay at 200. And you kind of already knew that my position needs to stay at 200 for these whole 5 seconds in order to indicate a velocity of 0, right? A position time graph is flat when the velocity is 0. The last section of the graph is going to be from 15 to 20 seconds. And I'm going to do the same analysis where I have to find the area under the graph in order to find my displacement. And so for this last section here, the area under the graph for my displacement is the base times the height. I'm writing my equation first. And so that displacement is going to be 5 seconds at, this time I'm going at negative 15 meters per second. So negative 15 meters per second because I'm going in the negative direction. When I do that, I get negative 75 as my displacement. That does not mean I go down to a position of negative 75. That's wrong. Instead, what that means is that the difference in my positions needs to be negative 75. So my final position minus my starting position has to be equal to negative 75 meters. I'm looking for my final position, and my starting position is where I was at last time. I was at 200 meters last time. And so now I'm going to try to figure out x minus 200 has to equal negative 75. So if I take negative 75 and I add 200, I get positive 125. My final position has to be positive 125. At the end of 20 seconds, I'm going to go up here and say that 120 is right here, but I have to be at 125, so I'm going to go like right in here. And I'm going to say that I have to end at a position that's equal to positive, right up here, 125. And so that is how you go from a velocity time graph to a position time graph. You use the area to find your displacement, and then you just only have to plot the endpoints of those line segments.